In this section, we're exploring the key technologies behind AI that helps computers learn, think, and understand like never before. From making smart choices to creating new things and even talking, let's dive into our first technology, reinforcement learning, the foundational method behind teaching AI. Reinforcement learning is like a game of hot and cold. Imagine you're searching for treasure in your backyard without a map. Each step you take, somebody tells you warmer if you're getting closer, or colder if you're moving away. Eventually, you find the treasure by understanding which actions lead you in the right direction. Computers use reinforcement learning in a similar way. They try different actions, get feedback, and figure out the best steps to reach a goal. This is how some video games train their AI to challenge human players, or how companies optimize their delivery routes to save time and fuel. Next, having explored how AI learns from actions and feedback through reinforcement learning, let's delve into its ability to generate and innovate. We're moving into the domain of variational autoencoders, where AI's creativity comes to life. Variational autoencoders, or VAEs, are a type of AI that learns to compress data into a smaller encoded representation and then reconstruct it back to the original form. This process allows them to capture the essential features of complex datasets and generate new data points that are similar but not identical to the original. Think of VAEs as the ultimate art student. First, they study a bunch of pictures, learning about styles and techniques. Then, instead of copying what they've seen, they start creating their own art, something new but influenced by their studies. For AI, this means taking in lots of data, finding patterns, and then using those patterns to generate new data that still makes sense. This technology is behind some of the cool filters you see in photo apps, where you can turn your selfie into a piece of art. Or it can help designers come up with new concepts by remixing old ones. Now that we've seen AI's creative side with variational autoencoders, let's step into an advanced arena where creativity is sharpened by competition. We're entering the sphere of generative adversarial networks, a recent development that has played a large part in the incredible improvements in image generation. Generative adversarial networks, or GANs, are a type of AI learning system that uses two neural networks, two different AIs, and pit them against each other, consisting of 1, a generator that creates data, and 2, a discriminator that evaluates it, in order to improve each other's performance and produce highly realistic outputs. GANs can be compared to a game of cat and mouse. One AI, the generator, is tasked with creating counterfeit artwork so convincing they could hang in a gallery, while the other, the discriminator, acts as the art critic, trained to detect any fakes. Each round of this game forces the generator to refine its technique, creating increasingly believable forgeries, while the discriminator sharpens its ability to spot the slightest inconsistencies. This continuous challenge and response drive both AIs to evolve, enhancing their capabilities until the forgeries are indistinguishable from genuine pieces. GANs harness this competitive dynamic to create and refine digital content, leading to breakthroughs in fields ranging from art and design to medical imaging and beyond. After observing the dance between the generator and discriminator in generative adversarial networks, we now explore transformer models, which harness similar principles of continuous learning and adaptation to master the complexities of human language. Transformer models are like having a conversation with somebody who listens carefully and always knows the right thing to say. These models are designed to handle language by paying attention not just to the words being used, but how they're connected in sentences and paragraphs using natural language processing. This helps the AI understand the full meaning of what's being said or written. So, when you ask your phone a question, it can give you a helpful answer. Or, when you use a translation app, it can convert your message into another language accurately. Transformer models are the reason we can have chats with AI on various websites that feel surprisingly human. From reinforcement learning smart choices to the creativity of VAEs and GANs, leading up to the transformer model's incredible language skills, we've seen how AI technologies build on each other to do awesome things. These advancements aren't just about making machines smarter. They're changing how we live, work, and communicate.